All right, so next we're just going to do some practice of being able to correctly identify if something is a polynomial and then stating its degree and leading coefficient. Okay. Now keep in mind that these equations might not be in standard form. So when we are stating the degree, it is always the highest degree. And it should be after we've simplified. So if they aren't simplified, then you're also going to need to do that before you state what the degree is and what the leading coefficient is. Okay. And remember, when we're talking about polynomials, it's in one variable. So if we have more than one variable, it's not a polynomial, so we won't be able to identify the degree or leading coefficient. And all of the exponents also need to be positive. Because remember, a negative exponent implies a fraction, and if we have a variable down in the denominator of a fraction, then it's a different type of equation. It's no longer a polynomial function. So go ahead and pause the video and see if you can answer these next set of example problems. All right, so as I'm looking at problem 1, our highest degree is 5. So again, we would say that that is a quintic. And then the leading coefficient would be 8 because that's the number in front of our variable with that highest exponent. Okay. This one is not a polynomial. And that's because we have more than one variable. Okay. So I'm just going to circle that to indicate it for my explanation as to why it's not a polynomial. Okay. And then if that's the case, then I can't figure out my degree or leading coefficient. Okay. All right, so next one, we have a degree of 3. So again, we would say that that is a cubic equation. And then the leading coefficient would be -5. So we have to make sure that we're keeping that sign in front of it. Next one, we have a degree of 4. So that is quartic with a leading coefficient of -2. And the next one is not a polynomial. And again, that's because of a variable being in the bottom of a fraction, so that's not allowed. So that also means I can't list the degree or leading coefficient. Okay. And then that last one, we have a degree of 1, which is a linear function, and a leading coefficient of 4. Okay. All right, so next, kind of back to our basics of evaluating. So remember, when we're asked to evaluate, we are substituting something in and then simplifying it as much as possible. Now, as we look at this, our equations are listed to us in function notation. So this is the name of our function and then what the function is. Same thing, this is the name and then what the function is. Now, normally when we evaluate, it's because we're trying to find a point on a graph. So usually we're just substituting in numbers. But as we advance further in math, that's not always going to be the case. So sometimes we're going to have to start evaluating other expressions into functions. So meaning we're going to be dealing with variables. So on 7 and 8, this is an example of that. So as I'm looking at this, this is wanting me to take -2 times the g equation. And at the same time, we're supposed to substitute 3c into all of the x's and then simplify. So I'm going to put -2, and I'm going to have a big parenthesis. And then I'm going to replace all of my x's with this. So I will have 3 from this equation. And then since I'm substituting in, I want to make sure I'm using a parenthesis where that x normally is. So this will be 3c, and then cubed, plus 5 times 3c minus 2, and then I'm closing this parenthesis. Okay. So you could also use a bracket in that case, but it's going to mean the same thing. So now we're just going through our correct order of operations to simplify this as much as possible. So I need to start with this exponent. So 3 times itself 3 times. So 3 cubed is going to be 27. So right now that -2 is staying there, and then that 3 is there. So this will be 27c cubed. And I need the parentheses there still because I haven't done anything with what's in front. And then we're also allowed to multiply this together. So 5 times 3c is 15c. And then I still have that minus 2. And then I'm going to close that parenthesis. Okay. So next we're here. So 3 times 27 is going to be 81. So this will be 81c cubed plus 15c minus 2. Okay. And I can't combine anything else inside, so that means that I am ready to distribute that negative 2 in. So negative 2 times 81 will be negative 162c cubed, and then minus 30c plus 4. So this will be my final answer. So next one is similar. So this time we are using the H equation, substituting this in to all the x's. So again, I'm going to use a parenthesis as I'm replacing the x. Now because of that subtraction in the middle, we're not allowed to use our shortcut rule where we just square everything inside. Instead, we have to write this out twice. And if this would be a 3, then I would write it out 3 times. And then we will have to FOIL. So if I FOIL this together, that will give me y squared minus 3y minus 3y plus 9. And then I still have that plus 4 on the end. So this will be y squared minus 6y plus 13 for that final answer. All right, so next we're going to get into what our graphs can look like.